Hi guys, today we're going to be talking about the difference between rational and irrational numbers. Okay, so how we're going to start is by writing down this little acronym that we want to remember. So let's try to remember these letters. F-R-T-P. Okay, so let's try to remember that. F.R.T.P. You can think of a funny mnemonic to help you remember that. I don't know, funny rabbits take pictures. Okay, so whatever you want to use to help you remember. So this is what's going to help us to understand what rational numbers are. Okay, so let's start with F first. The F stands for fractions, okay? So if a number can be written as a fraction, then it's rational. What is a fraction? Well, it's any integer, like a over b, any integer, where b is not equal to 0, okay? So obviously we all know fractions, right? 1/2 is a fraction. 3/4 is a fraction. 15 over 45 is a fraction. You can even have improper fractions, like 10 over 6, right? These are all fractions. What about negative fractions? Yes, negative 5 over 6, right? These are all fractions. What about integers, like 5, right? Can that be written as a fraction? Yes, it sure can. Why? Because any integer can always have 1 as its denominator, right? What about negative 28, right? Yes. How can you write that as a fraction? Negative 28 over 1, okay? So if a number can be written as a fraction, right? Any integer, a over b, where b is not equal to 0, then that means we are rational, okay? All right, let's go on to the next one. What does the R stand for? So the R actually stands for repeating decimals, okay? So a repeating decimal. Okay, so what's an example of a repeating decimal? Let's say 0.33333, and we keep on going on and repeating, right? We don't sit there and write that whole thing. How do we write that? As 0.3 with a line over the 3, indicating that 3 is repeating. Okay, let's do another example. Let's say 5.12121212. What part's repeating? The 1, 2. So how would we write that? As 5.12 with the line above the 1, 2, right? So that shows that it's repeating. Let's do another one. 1.2545454. Okay, so that's repeating, right? But what part's repeating? Not the 1, not the 2, but the 5, 4, right? So that line is going to be above the 5, 4. All right, so obviously these are repeating decimals. Again, repeating means it keeps on going on and on forever, but it's repeating the same numbers, okay? Now, did you know that repeating decimals can actually be written as fractions as well? Okay, so we will probably cover that in another video, but just suffice to say that this can actually be written as 1/3. So 1/3 is actually, when you do it on a calculator, 1 divided by 3 gives you that repeating decimal. What about 5.12 repeating? This actually gives you, as written as a fraction, is 5 and 12 over 99. Okay, so put it in a calculator, try it out. Okay, what about this one? So this one's a little trickier, but it is. You can also write it as a fraction. So this is 1 and 14 over 55. Okay, again, put it in the calculator, see what it gives you. All right, so we've covered the F and we've covered the R. All right, so let's clear this off and let's move on to the T and the P. Okay, so what we'll do is we'll write our acronym up here again. So remember, funny rabbits take pictures. Okay, so let's cover the T. So the T stands for terminating decimals. Okay, so let's say some examples of a terminating decimal. What does that mean? Well, 5.7, right? Why is that terminating? Another word for terminating means ends. It ends. It doesn't keep on going forever and ever, right? So 5.7, that's it. It's done, right? What's another one? 6.35. it's done, right? It doesn't keep going on and on and on forever. It stops. It's not repeating, right? Another one, 3.875, right? That's terminating. It stops, right? Now again, as with repeating decimals, terminating decimals can also be written as a fraction. Did you know that? So 5.7 is really 5 and 7/10. Okay, 6.35, if you turn that into a fraction, that's really 6 and 7/20. And 3.875 is really 3 and 7/8. Okay, so notice these terminating decimals, terminating means again, it ends, it doesn't keep going on and on forever, right? They can also be written as our F, our fractions, right? Okay, making sense so far? So remember, F stands for fractions, R repeating decimals, T terminating decimals. Now P, that stands for anything that is a perfect square, okay? Now, what does a perfect square mean, right? That means any number, right, that multiplied by itself would give you a perfect square. So let's talk about some examples. Let's say 16. Is 16 a perfect square? Can you take the square root of 16? Yes, you sure can. You get 4. What about 100? Yep, that's a perfect square. You take the square root of 100, what do you get? 10, right? What about 169? Is that a perfect square? Yes, it sure is. You take the square root of 169 and you get 13, right? So notice perfect squares, again, are numbers, right? When you take this number, this integer, you multiply it by itself, you're going to get a perfect square. This number multiplied by itself, you get a perfect square. 13 multiplied by itself gets you that perfect square, okay? So perfect squares are rational numbers. Why? Because they give you, right, the answer is just a regular integer. And what do we say? Regular integers are rational numbers because they can be written as a fraction, right? That's 4/1, 10 is 10/1, and 13 is just 13/1, right? Okay, so a recap. F.R.T.P, fractions, repeating decimals, terminating decimals, and perfect squares, okay? So these are all rational numbers, okay? So let's clear this for a second. All right, and again, so F.R.T.P. Do you remember what that stands for? Fractions, repeating decimals, terminating decimals, and perfect squares, okay? Now, it's interesting that an irrational number is not any of these, okay? So it's just the opposite. So if you're not a fraction, if you're not a repeating decimal, if you're not a terminating decimal, and you're not a perfect square, guess what? You're going to be irrational, okay? So let's talk about an example, right? Let's write this number, 5.1873527, and it just goes on and on, right? Is this a fraction? No. Is this a repeating decimal? No, I don't see anything repeating here, right? Is this a terminating decimal? No, these little dots means that it goes on forever and ever, right? Is it a perfect square? Nope, there's no number that I can multiply by itself that would give me this, right? So the fact that it's not terminating, it's not repeating, it's not terminating means this is not rational, so that means this is irrational number, an irrational number, okay? Let's do another example. What about the square root of 18, right? Is that rational? Is that written as a fraction? Nope. Is it a repeating decimal? If you plug this into your calculator, you will not get a repeating decimal. Is it a terminating? If you plug it into your calculator, it might seem that it will give you a terminating number, but no, it will go on and on and on forever, okay? And is it a perfect square? It sure isn't. No, it's not. Let's write down our perfect squares. Remember what? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Oh, guess what? 18 would be somewhere in this realm, right? And so it's not a perfect square. So this means, right? Remember, if it's not one of these, then we are irrational. Okay? Let's talk about, let me list 4 numbers, okay? 4 numbers. Let's try 15/3, -12.7, the square root of 15, and 25.82, repeating. Okay, So let's go through and can we tell and list what each one of these are, right? Okay, so 15 over 3. Is it a fraction? Yeah, it's a fraction. Done. Okay, it's a fraction, so guess what? That's rational. Okay, what about this one? Fraction? No. Repeating? No. Terminating? Yes. Yep, it's terminating, so it's rational. Okay. What about this guy? Fraction? No. Repeating? No. Terminating? No. Perfect square? No. Remember, we listed our perfect squares earlier. So it's not any of these. Remember, irrational means I am not any of these guys, right? So I'm not any of those, so that means I am irrational. Okay? The number, the square root of 15 is irrational. What about this one? 25.82 with the line above the 82. What does that mean? So that is what? 25.82, 82, 82. Okay, that's what that means. Is it a fraction? No. Is it a repeating decimal? Yes, it sure is. It's repeating. So that falls under my R, so that means I am rational. Okay? So hopefully this is making sense, guys. All right, let's write these numbers. The square root of 17, the square root of 168, 15.45, repeating, and pi. Okay, so are these rational or irrational? Remember, irrational means I'm not any of these things here, right? Square root of 17, is that a fraction? No. Is it a repeating decimal? No. Is it a terminating decimal? No. Is it a perfect square? No. So, no. So that means I'm not any of these things, so that means I'm an irrational number, okay? What about this? The square root of 168. No, that's not a perfect square. The square root of 169 is a perfect square, right? So it's not a fraction, not a repeating decimal, not a terminating decimal, not a perfect square, so that means this is irrational. Okay, let's do another one. 15.45, repeating. Where is this going to fall? Right here under my repeating, right? So that means I am rational. Okay, what about pi? Well, if you know what the number pi is approximating, we typically say 3.14, but in reality, that's not it. And it keeps on going and going. And guess what? It's not a fraction. It's not a repeating decimal. It's not a terminating decimal because it goes on and on and on forever. It's not a perfect square. So it is not any of those things. So if we're not any of those things, we're not the F.R.T.P, funny rabbits take pictures, that means we are irrational. Okay, so hopefully these things, these examples have helped out a little bit. Again, just remember that mnemonic, funny rabbits take pictures, okay? Fractions, repeating decimals, terminating decimals, and perfect squares. If we are any of those things, we are a rational number. If we are not those things, that means we're rational, okay? Hopefully that makes sense. Take care. Until next time. Bye.